Hi everyone. So the first derivative test is a test to find the relative extrema of a function. And before we begin, I want you to keep these three rules in mind. Because the derivative is the slope at a point, we know that if it's greater than 0, then f of x must be increasing at that point. If it's equal to 0, then f of x is constant at that point. And if it's less than 0, then f of x must be decreasing at that point. Okay, so here we have a function, and here we have its derivative. So what we can first note is that graphically looking at it, there's a critical max, or a relative max, at this point, right? At x equals 0. We also know that this relative max occurs at the critical number, or where the derivative is equal to 0. So what we can do now is we can plot the critical number, x equals 0, and we can note that before this critical number, the derivative is positive, so we write a plus sign here. And after the critical number, the derivative is negative, so we write a negative sign here. So what this tells us is that before this critical number, the function is increasing, like this, and after the critical number, the function is decreasing, like this. And so if you look at this, it looks a lot like there's a critical max here. And looking at it, the function itself, there is a critical max. Relative max. I keep saying critical max. Relative max. So this is essentially the first derivative test. So if you want another example, please keep watching this video. Otherwise, that is in fact the essence of the first derivative test, so you can stop here. But here's the next example. Here we have another critical number. So we mark that as some critical number. And here we have another function. So we know that from here to here, the derivative is negative, right? Because the function is decreasing. So we write a negative sign here. And after this point, the function is increasing. So derivative must be positive. So we write a plus sign here. And so this function looks kind of like this. And so we know that there's a relative min without graphing the function. Okay, so just to show that not all functions have really comprehensible number line-ish things. So let's look at this function. At this function there are 4 critical points. Our derivative is 0 here. It's also 0 here. And it's also 0 here. Okay. But we know that there's only one relative min here, and that's at this point. Here, the function looks kind of like this. And then the function starts looking like this. So from here to here, there's neither a relative min nor a relative max. There's only a relative min here. So I just wanted to give this as an example of how crazy some functions can look like. But yeah, the first derivative test does help you find the relative mins or the relative maxes. So I hope this helps, guys. Thank you, and have an awesome time in calculus.